The highly profitable, innovation-focused game console company Nintendo, trained and dedicated to Six Sigma techniques, released the Game Boy Advance, a 32-bit handheld gaming console, on March 1st, 2001 in Japan and June 11th, 2001 in North America. Often abbreviated to GBA, the handheld gaming console sold over 81.51 million units in the 9 years following its launch. Its initial price upon release was $99.99, or 13,477.5 Japanese yen. The GBA was discontinued in 2006 in Japan and 2008 in North America. The used GBA is worth between $39 and $155, depending on its condition and whether the console comes boxed or with accessories or games. However, the average GBA goes for $109.95 as of fall of 2021. We got ours for a whopping 50 cents at a yard sale, and our bank account will never recover. The main target audience for the console was children and teens, but many adults fell in love with the GBA too. Many popular games include The Legend of Zelda: The Minish Cap, Mother 3, Metroid Zero Mission, and Pokemon Ruby and Sapphire, which is my personal favorite Pokemon game.
Nintendo as a company adheres to Lean and Six Sigma principles, meaning that many components of the assembly, for instance the ABS plastic clamshell halves of the main body assembly, or the hard plastic buttons, all fall within a tight tolerance of their desired dimensions, giving a high reliability to the components. The sub-assemblies of the Game Boy Advance, visible in the bill of materials present, breaks down into the following 5 sub-assemblies: the main body assembly, the electronics assembly, the hard buttons assembly, the soft buttons assembly, and fasteners. The main body assembly, composed of the console front face with the display, the console rear face, and the cartridge smooth contact plate, has one of the highest cost ranges of any of the sub-assemblies of the Game Boy Advance. Both of the faces, with the exception of the screen, are composed of an ABS injection molded plastic, which reduces the cost of manufacturing each of these clamshell halves that encase the entire assembly. The electronics assembly of the Game Boy Advance compose the majority of pieces which facilitate the electrical functionality of the Game Boy Advance. Most of these pieces are made through complex processes producing printed circuit boards or electrical components. The electronics assembly is composed of the external speaker, the main PCB, the game cartridge, and 2 AA batteries. It could also be argued that the screen is part of this sub-assembly. However, for the purposes of our component breakdown, it was useful to bind the screen to the main body assembly. The hard buttons assembly composes all of the functional buttons plus additional injection molded parts that allow for the player to press buttons and play the game on the Game Boy Advance. The hard buttons assembly contains 2 forward triggers with springs, ergonomic side panels, the rigid D-pad button, the rigid A button, rigid B button, and the black support piece. All of these pieces are manufactured out of an ABS plastic, which again reduces cost for Nintendo and allows for tight tolerances. The soft buttons assembly is composed of TPU pieces which allow interface between the hard buttons and the circuit board itself. The soft buttons assembly is composed of the soft D-pad button, the soft A and B buttons, and the soft start select buttons. It is important to note that while these pieces are also injection molded, because of the flexible plastic material, the method is slightly different. The final assembly of the Game Boy Advance is the fasteners sub-assembly, composed entirely of stainless steel fasteners which were produced by thread rolling. The assumption is that these parts were commercial off the shelf. The fasteners sub-assembly is composed of 2 PCB internal screws, 2 cartridge connection face screws, 4 PCB to body screws, 2 side body screws, and a bottom body screw. Some final notes on the product design that are of value are to note that the majority of the pieces of the Game Boy Advance are custom built for the console, rather than being composed of commercial off-the-shelf parts. This is from a product design standpoint of making Nintendo's product seem individual and functional, as well as interesting to the consumer. The most complicated piece of this assembly is most likely the main PCB. The vast majority of the parts for the Game Boy Advance that are composed of plastic are composed of an unknown gray ABS plastic. It's assumed that this is a proprietary mix and not a raw ABS mix, however, this information is not publicly available. One improvement we would recommend would be to make the volume wheel detachable to clean. It is a common issue for them to get dirty and ruin the functionality of adjustable volume. A second improvement would be to increase the thickness of the battery panel, thickening the plastic panel to 1.5 times or greater of its prior thickness, and to add 2 additional fastening points on the top left and right of the panel to better reinforce the battery panel binding. These improvements would aim to improve the strength of the plastic battery panel. A third and final improvement would be to increase the wire gauge between the PCB and the built-in speaker, the reinforcement on the connections between these two electronics, e.g. the soldering, and the wire between, and to replace the speaker itself with one more capable of a greater current, resulting in a greater volume. This improvement set would aim to reduce the chance of the wire from the PCB to the speaker breaking off and causing the speaker to stop playing, and have the added benefit of facilitating a greater speaker volume from the GBA. One downside of this potential improvement would be that the greater power draw needed for the speaker would reduce the battery life of the console.
Using the knowledge we gained from MCEN 4026, we noticed that the GBA assembly is rather efficient. All of the injection molding is fairly simple, and there's only one PCB, which stands for printed circuit board. The most complex injection molding part was the front housing, which only has a few side action cam holes, while the vast majority of the holes are from straight poles. The buttons and user inputs are all injection molded with relatively simple geometries composed of ABS and TPU. The buttons have extrusions that fit into notches on the housing to prevent them from spinning or rotating. One of the improvements we had was to fix the volume wheel. This is feasible by adding a different removable fastener instead of being press-fit and glued. The idea of upgrading the speaker and wire would also be feasible, but might not be worth it due to the decrease in the battery life it would cause. Lastly, the thickness of the battery plate would also be feasible as well as effective because it would fix one of the biggest complaints people have about the GBA. The GBA was a solid gaming console of its day. The improvements from previous Nintendo handheld consoles helped progress the industry towards more advanced handheld devices, like the Nintendo Switch.